Okay, today we're going to practice our implicit differentiation again. And we're going to differentiate sine x times y equals cosine x plus y. And let's remember that this isn't sine times x times y or cosine times x plus y. These are composite functions. So this on the left right here, sine x times y, is actually sine x composed with x times y. And cosine x plus y is actually going to be cosine x composed with x plus y. And so we're going to need to use the chain rule on both sides. Since this is implicit differentiation, our first step is going to be to just derive both sides of the equation separately. So we're going to take dy dx of sine of y times x, or x times y, whatever you want, equals dy dx of cosine of x plus y. Now let's do the left first. Let's do the left first. The derivative of sine is cosine, whatever the variable is. And since this is going to require the chain rule, the derivative of sine of x times y is going to be cosine of the inner function. So that's x times y is the inner function, cosine of x times y, times the derivative of the inner function. So let's just write d over dx of x times y for now, and we're going to do that on the next step, equals, and now we're going to do the same thing on the right. So the derivative of cosine is negative sine x or y or whatever it is that is in your argument right here. So it's going to be negative sine of x plus y times the derivative of the inner function. And since the derivative of a sum is the sum of its derivatives, we're just going to go ahead and skip that step and write dy dx of x plus dy dx of y, which is actually just going to be dy over dx, and that's going to be what we're solving for. We're going to have two of those floating around in this function, in this equation. So let's just write that down now. This is going to be important. X derived with respect to x is just going to be 1, but we're going to write it down so we know what we did if we go back and look at it. So now we've got cosine of x times y times dy dx of x times y. Now this is going to require the product rule. So we're going to take x times y prime plus y times x prime equals negative sine of x plus y times 1 plus dy over dx. Okay, so our next step is going to be to roll out this product rule right here to take the derivative of y. Now the derivative of y with respect to x is also dy over dx. That's going to be our second one of these here. And x prime is just going to be 1 again, so we're going to end up with cosine of x times y times x times dy over dx plus y times 1, which is just y, equals negative sine of x plus y times 1 plus dy over dx. Always write the brackets, because the second that I stop writing the brackets, because I think I can remember, my multiplication and my subtraction and my addition get all messed up and I end up with the wrong solution. So I've learned my lesson. Always write your brackets till the very end. So the next step is, I'm going to go to the top right now, is going to be to FOIL this out, to multiply it. So we're going to multiply cosine of x times y with x times dy over dx plus y. So we're going to end up with x times dy over dx. Actually, I'm going to move this over a bit. Otherwise, we're going to run out of space. So I'm going to end up with x times dy over dx times cosine of x times y plus y times cosine of x times y on the left. And on the right, we're going to end up with negative sine of x plus y plus negative dy over dx times sine of x plus y. Looks intimidating, isn't really. We just have to get the dy over dx's on one side because that's our derivative. That's our slope of the tangent line. And we have to get everything else on the other side. So the next thing that we're going to do is we're going to subtract this right here. We're going to subtract this from both sides. And we're going to add this to both sides. There actually doesn't need to be a plus right here because we have a negative. Okay, so let me get my color back. All right, so what we're going to do is we're going to end up with x times dy over dx times cosine of xy plus dy over dx times sine of x plus y equals negative sine of x plus y minus y cosine of x times y. Now we're going to factor the dy over dx's out by grouping. Here are our dy over dx's right here. And we want to factor those out by grouping. So we're going to take a bright color so we don't get confused with the left side of the page. And we're going to end up with dy over dx times x cosine of xy plus sine of x plus y equals negative sine of x plus y minus y cosine x times y. We're going to just divide by all of this right here. We're going to divide by this argument right here. And our solution is going to be, solution is going to be dy dx equals negative sine of x plus y minus y cosine of x times y all over x cosine of x times y plus sine of x plus y. And that is our derivative.